projects. In this video, we are going to explain about the project which is improving healthcare prediction of diabetic patients using KNN imputed features and try Ensemble model. Before getting into the execution, first let's understand what is the project. As we all heard the term diabetes mellitus, it is a chronic disease that has become a serious global issue due to its rising prevalence and severe conditions such as cardiovascular diseases and also nerve damage. For instance, patient experiencing fatigue and frequent urination that may be misdiagnosed if their medical records are incomplete, leading to untreated high blood sugar and serious health risks. So healthcare professionals they play a crucial role in managing diabetes, but traditional diagnostic methods they are time consuming and they may delay the treatment. In rural clinic, if a doctor lacks access to patients' complete medical history, it may result in ineffective management of their condition. So this situation emphasizes the need for advanced diagnostic tools that leverage machine learning and data-driven models to improve prediction, accuracy, and enable timely interventions, ultimately preventing complications and enhancements in patient care. The main challenge we face is finding effective ways to detect diabetics early. So the main issue is detecting diabetics early. As this can significantly lessen both the health issues and also financial costs associated with the disease. While we have some machine learning models and data mining techniques which are present a great potential for creating predictive models, their accuracy can be compromised by missing or incomplete data. So, although we use these machine learning models, if it comes to dealing with the missing data, they prove in the inaccuracy part. That means they don't achieve the highest accuracy. So, therefore, it is essential to develop a strong solution that can tackle these data related challenges and provide dependable predictions, ultimately improving the diagnosis and treatment outcomes for patients. So, to tackle all these issues of delayed diagnosis, incomplete data, and inaccurate predictions in managing diabetes, this project introduces a tri-ensemble model for diabetes prediction. So, this model combines three powerful algorithms that is, extra-tree classifier, extreme gradient boosting, and random forest, which work together through a voting mechanism. So, these algorithms they will be combined in the voting classifier. So these algorithms, all these three extra-tree classifier, gradient boosting, and random forest, they will be combined in the voting classifier algorithm for enhancing the accuracy of predictions. One of the significant hurdles we face in the diabetes diagnosis, missing data. So we talked the issue of missing data, right? So this issue is addressed by using the K nearest neighbor. So here we use this K nearest neighbor imputation to fill those gaps and improve the overall quality of the data. This approach ensures that the healthcare professionals have a reliable tool at their disposal for making timely and accurate diagnosis. Ultimately, this can lead to better patient outcomes and help reducing the financial strain associated with the diabetes care. Moving on, as the extension to this project, we are introducing stacking classifier. So this stacking classifier is the new model that combines two different approaches. All the ensemble models, they combine different models. So in the stacking classifier, we are combining bagging classifier, which uses random forest as its base, and the decision tree that employs the light GBM. So this combination aims to further improve the accuracy of the diabetes prediction. And to tackle the issue of missing data, we are using the K nearest neighbor. So stacking classifier will be built with the imputed KNN feature values and without the KNN imputed feature values, and then we'll be comparing the accuracy if with KNN computed feature values accuracies will be high or without. And moreover, we have created a user-friendly front end using Flash framework. So here we have built the front end using Flash framework. This interface allows healthcare professionals to easily access the system, making it simple for them to obtain timely diagnosis and make better clinical decisions. Overall, these enhancements aim to provide a more effective tool for managing diabetes. Moving on to the flow of work, that is how we implemented the project. First, we have imported all the packages which are necessary. And then we have explored the dataset, that is diabetes dataset, to understand the structure and the content. After gaining insights from the dataset, then we have followed with the next step, that is data processing, which includes removing the duplicate values, cleaning the data, and encoding the label values, that is to prepare the categorical variables into numerical variables. Moving on, then we have did exploratory data analysis. It is conducted for feature selection, that is featuring a correlation matrix and a sample outcomes to identify the relationship among variables. Next, we selected the features. It is performed, identify the input features as X and the target variable Y, essential for training the machine learning model. And to address missing values, here we have employed a nearest neighbor imputation. It is empty, enhancing the dataset's completeness. The dataset is then split into training and testing sets. So the dataset is next split into training and testing sets to facilitate model training and the evaluation. Once the dataset preparation is complete, various machine learning models are built. So once the data is prepared, we train the models. And the models are compared based on the accuracy, precision, recall, and FN score. So once the models are trained, we compare them using accuracy, precision, recall, and FN score, and then we compare the graphs of all the models. Coming to the front-end part, following the model evaluation, a front-end interface is developed using Flask framework, which includes registration and login system supported by an SQLite 3 database. After setup, so users, they will be able to give input features through this interface. The provided input undergoes pre-processing for prediction purpose. And then final outcome will be, the pre-processed data, it will be trained on the model for the prediction, and then it will display the output, whether the person has diabetes or not. So coming to the algorithms used, we have used logistic regression, decision tree, random forest, stochastic gradient descent, extra tree, XGBoost, support vector machine, naive Bayes, voting classifier, which is the proposed one, and the extension is the stacking classifier. So among all the models evaluated, we found that the extension stacking classifier with the KNN imputed feature values has got the highest accuracy. So we have used it for prediction in the front end. So we have deployed this stacking classifier model in the front end. Moving on to the requirements, to implement this project, we need some basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap. So this is all about the theoretical concept. Now let's execute it. To execute, we need to open the code folder which contains source code files. So let's open the code folder. These are the source code files in the code folder of the project. Let's understand each of them, how will they be used in the project. So the first file, that is the first folder, we have a static folder. In this folder, we have CSS, JavaScript, and Bootstrap files. These files are important for the project's styling and visual interactivity. Coming to the templates folder, in this folder, we have HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. This is the dataset that is used in the project to train the models to predict the diabetes. So these are all the features that are independent features which influence the diabetes. So we'll be using all these features to train the model to predict this last variable, last column, that is the target column. Here 1 means person has the diabetes and 0 means person has no diabetes. Now let's close this. This is the sample file in which we have the test cases. So we'll be using these as the test cases to predict the diabetes in the front end. So we'll be using them as a test cases. Close this. And this is the database file, that is signup.db file. This file is used to store the user information. Here last two files we have that are Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in the individual cells, which makes it a popular choice for the data sets. So in this first Jupyter Notebook file, in this file, the data set has been imputed. I mean, missing values in the data set are imputed with the KNN imputer, and then algorithms are trained on the imputed features of the data set. In the next data set, missing values are not imputed with the KNN data set. So here on the direct data, all the algorithms have been trained. Now let's execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So let's copy the path. Now open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. Here, if you observe, current directory is changed to the code folder's path. Now we have to compile the app.py file. So give the command python space app.py and click on enter. So this command, it will execute the Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application at the default address, which is the local host and the port unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here at the end, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we have to sign up, so click on sign up and give all the registration details if we are registering newly. If we have already registered, we can directly sign in, so click on sign in. As I have already registered, so I'm directly signing. So give the username and the password. Click on login. I have logged in successfully and redirected to prediction page. So if you observe the prediction page, we can see the parameters which are need to be given as input. So for these parameters, we are supposed to provide the input. Based on the provided input, we get the prediction. Let's understand each parameter. Coming to pregnancies, it is a parameter that indicates the number of times that the individual has been pregnant, which can influence diabetic risk, particularly gestational diabetes. So coming to glucose, it is a measure of the blood glucose level, as elevated levels can be strong indicator of diabetes. The next one we have is blood pressure. This parameter represents the individual's blood pressure readings, where high blood pressure is often associated with an increased risk of diabetes. Coming to skin thickness, this measures the thickness of skin fold, typically at the triceps, which can indicate body fat and insulin resistance. Coming to insulin, this parameter reflects the level of insulin in the blood, which is crucial for glucose regulation, and it will indicate body's ability to process the sugar. BMI is nothing but body mass index. This is a measure of body fat based on height and weight, where a higher BMI is linked to a greater risk of developing diabetes. Coming to diabetes pedigree function, this parameter evaluates the genetic predisposition to diabetes based on the family history and the other genetic factors. The last one we have is age. This indicates the individual's age, as the risk of developing diabetes typically increases with the age. So we understood all of these factors. Now let's enter them. Let's give inputs to these parameters. As I already told you that here we'll be giving test cases, and those test cases are in the sample folder. So let's open it. So these are the test cases. So we'll be filling all these parameters. Let's use the first test case, whose outcome is 0, which means that person has no diabetes. So let's check whether the application will correctly predict or not. So let's give the pregnancy as 6. Glucose is 98. Blood pressure is 58. Skin thickness is 33. Insulin value is 190. BMI is 34. Diabetes pedigree function is 0.43. The last which we have is 43 as age. Now click on print. So your application has correctly predicted that the person has no diabetics based on the given input. So that given input, it will be processed at the backend, and train model will be used to give the prediction. So here the train model which is being used is starting classifier. Now let's give other set of input. Let's go with the 12th test case. whose outcome is 1, which means person has the diabetics. So let's give pregnancy as 10. Glucose is 111. Blood pressure is 70. Skin thickness is 27. Insulin is 68. Body mass index is 27.4. Sorry, 5. Diabetes prediction is diabetes pedigree function is 0.141 and the age is 40. Let's click on predict. So here we got the prediction as person is suffering with the diabetes. Based on the provided input, the application has correctly classified that the person is suffering with the diabetes. So now let's give other set of inputs. So click on prediction again. So let's give this 18th test case. So pregnancies are 3 pregnancies. Glucose is 84. Blood pressure is 72. Skin thickness is 32. Insulin is 77. Body mass index is 37.2. Diabetes pedigree function is 0.267 and the age would be 28. And here we have outcome is 0, which means application should predict as person is not having the diabetes. Let's check whether it will correctly predict or not. So click on predict. So here application is correctly predicting that person has no diabetes. Let's check with the other test case. Click on prediction. So let's check with this. The 6th test case, the 5th test case. So here the pregnancies would be 0, that means no pregnancies. Glucose is 167. Blood pressure is 74. Skin thickness is 19. Insulin is 125. Body mass index is 32.3. And the diabetes pedigree function is 0.839 and the age would be 30. And outcome should be predicted as 1. That means per patient should have the diabetes. So let's click on predict and see whether application is correctly predict or not. So here if we observe, application is predicting all the test cases correctly that patient is not having diabetics here. Previously, all the test cases were correctly predicted. So in this way, we can understand that application is working perfectly. So now let's click on graph. Let's check with the graphs. So this is the sample outcome graph. Here on x-axis, we have the classes and on y-axis, we have the out. So 0, it represents persons with no diabetes and 1 represents the persons with diabetes. If you observe, persons with no diabetes are only having the high count. And this is the correlation matrix. It shows the correlation between the variables. And this is the accuracy graph for with KNN imputed features. So here missing values are addressed using KNN features, and for those data set, all the algorithms have been trained. So here on x-axis we have accuracy score and on y-axis we have all the algorithm names. If we observe, stacking classifier is having the highest accuracy. And this is the precision score. Here we have the recall score graph and here we have the F1 score graph. And here we have without KNN imputed, which means that missing values on the data set are not imputed using KNN and all the algorithms are trained on without imputed features data set. So this is the accuracy score graph. This is the precision score. This is the recall score, F1 score. And that's all. So by this, we can understand that algorithms which are trained with the KNN imputed features are performing well than the without KNN imputed features. And moreover, the extension model stacking classifier is performing well. Click on sign up. This project emphasizes the importance of leveraging technology to address the challenges of diabetes diagnosis and management. By ensuring timely and accurate predictions, it equips healthcare professionals with a reliable tool to make informed decisions, ultimately improving patient care and contributing to better healthcare outcomes. such as solutions play a crucial role in mitigating the growing impact of diabetes on individuals and healthcare systems worldwide. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.